So you guys showed me on your test that you're pretty good with radicals. You're pretty good at the idea with simplifying radicals, simplifying variables to powers, and understanding that division piece. And most of you did a pretty good job with the absolute value piece too, so that's really good. This is an extension of that, and it's a little trickier, and there's going to be some problems that don't work out as nice as the problems that we've been working on, and so that's what 6.5 is all about. We're going to look at these two problems, the square root of 12c to the 6th d to the 3rd, and then we're going to look at the cube root of 27y to the 12th z to the 7th. And we're going to talk about what makes these types of problems different than the ones that you've been doing. Here's our approach for this first problem. I want to think of these three parts as separate problems. Okay? So I'm going to think of the square root of 12, the square root of c to the 6th, and the square root of d to the 3rd. And what's different about this problem compared to other problems, the numbers just aren't going to be as nice. Now we could type the square root of 12 into our calculator and get an estimate using an approximation, round the answer and get a decimal answer, but that's not what we want to do, okay? What we actually want to do is try to figure out what is the biggest perfect square that goes into 12. So think about all your different perfect squares and think of the factors of 12. What is a factor of 12 that's a perfect square? 4. Is there any number besides 4 that's a perfect square that goes into 12? So let's think what our next perfect square is after 4. What's the next perfect square after 4? Because 4 is 2 squared. So what's the next one after that? What's 3 squared? 9. So 9 is the next perfect square after 4. Does 9 go into 12 evenly? No. What's the next perfect square after 9? 18. No. 81. Nope. 16. Very good. How'd you get that?
4 times 4.
4 times 4. 16 is bigger than 12, so obviously it doesn't go into it. So my biggest perfect square that goes into 12 is 4. And what we're going to do is we want to think about this as the square root of 4 times 3. Okay? And so what we can do is actually simplify the square root of 4. So that's going to be what? What's the square root of 4? 2. So the 2 comes out and the 3 stays in. Okay? So that's how we simplify radicals when they aren't perfect squares or perfect cubes or perfect fourths. When they don't turn out nice like they did in 6.4, we try to find a factor that goes into the number that is a perfect square. Okay? And so that's as far as I can go with the square root of 12. Now let's focus our attention on the square root of c to the 6th. You guys know how to do this one, right? What is this?
It's 2 divided by 6.
Otherwise,
C to the 3rd.
c to the 3rd, right? So 6 divided by 2, right? And that gives us 3, so that's just to the 3rd. We got a little bit of an issue there, right?
Yeah.
What's the issue?
It's not a number.
Odd power. Do I have an even situation to begin with?
Yeah.
Even, odd power. So I'm going to need absolute value. I'm not going to put them in quite yet, but we're going to need that. Okay? Now, let's focus our attention on the square root of d to the 3rd. This one's trickier because when I take 3 divided by 2, it doesn't work out evenly. So this is where the other new part of this section comes in play. Right? So we do our division, and I get 1, remainder 1, and I color-coded it on purpose. So the number of times that it goes in evenly is the power on the outside of the radical, like we have over here. The number that's the remainder is the power on the inside of the radical. So let me line that up for you. Okay? So this becomes d to the 1st, and since the remainder is 1, d to the 1st stays underneath. The remainder power stays underneath the radical. The number of whole number times that it goes in is the power on the outside of the radical. So let me talk you through that one again, because this is really the big new stuff. So 3 divided by 2. 2 goes into 3 one time with 1 left over. So the one time that it goes in evenly, that's the power on the outside. The remainder is the power on the inside, and they're both d because we're talking about d to the third. Okay. Questions on that before we bring it all together? Yes.
I'm confused on why, like, the remainder part.
So in reality, what this actually is telling us is, so let me show you just what this would look like if I broke it down into factors like we did over here. Okay, so if I broke this down, it would be d squared times d to the first, because that's d to the third, right? This part, square root of d squared is d, and then I'm still left with this d on the inside. So that's why it works, but I think as you guys have demonstrated to me in 6.4, that this division property works really good for you. So I want to stay with that idea, and because it doesn't come out evenly, we're going to have some leftover, and that's what that remainder is. Okay? Now, the next part is I've got in yellow all the things outside of the radical, and in green I have all the things inside of the radical. So my answer is going to be partly outside and partly inside. So I'm going to bring everything in yellow together on the outside. I'm going to bring everything in green together on the inside. So what it would look like when I bring it together is like this. So I have the yellows on the outside, 2c to the third d times the square root of 3d. Now I didn't put the d to the first on either one because we don't need to write d to the first, right? We know that that's also just d. Okay. Then I have one more move that we talked about a little earlier. Okay. Got an even, odd. Okay. In this case I have even odd, so it doesn't apply. So I've just got to put the absolute value on that c to the third, and now I'm good. And that's the problem. On some of these, the TI-30XS calculator that a lot of you have, it will simplify the square root of 12 into radicals for you. Okay? However, I'm not concerned with what your calculator knows, I'm concerned with what you know. Okay? So I need to see this. I need to see that you understand how to break down a number into its factors so that one of the factors is a perfect square or a perfect cube. Okay? So that's going to be important. So yes, you can use your calculator as a check, but I still want to see this. Okay? So that part's kind of new. This part with the remainder is new. Okay? This part is obviously not new. Bringing them all together under as one answer, that's pretty new as well. Okay? Let's shift over to the second problem. So again, we're going to split. We're going to think of them as the cube root of 27, the cube root of y to the 12th, and the cube root of z to the 7th. Fortunately, since the index is odd, we don't have to worry about absolute value at all. Okay? So I want you to try this one first. I know I just turned you loose on a problem like this, but it's okay if you don't quite get it right, but I want you to try it and let's see what we come up with. The first thing that we're going to do is the cube root of 27. What is that? 3. That actually works out nice, so that's good. So that's just 3. Okay. How about the cube root of y to the 12th? That one works out even too. Y to the 4th. Okay, 12 divided by 3. That comes to be nice and even, y to the 4th. Okay, so I have an issue with the z term, right? What is the cube root of z to the 7th? So what is 7 divided by 3, first of all? Let's talk about that. What is that?
2.2.
Yeah, but I need it in remainder form. So 2 what? What's the remainder? 1. 3 goes into 7 twice. There's 1 left over. So it goes in twice, remainder 1. So I need that remainder. The 2 becomes the power on z on the outside. The 1 becomes the power on z on the inside. And again, it's the remainder. It remains under the radical. Okay? The remainder remains under the radical. So what I end up with here is z squared, because that's what this power goes with. Z squared on the outside, z to the first on the inside is still the cube root. Now I can just bring those outside terms together. And since in this case they're already all kind of next to each other, I just got to squeeze them together a little bit. Okay, 3y to the 4th z squared times the cube root of z.
I got that.
Okay, good job. Questions on that?
Still don't understand a radical.
Okay, so this whole problem is a cube root problem. If there's ever a radical left over, like it doesn't come out nice and even like these two, then it's still a cube root. Right, the radical is still a cube root. Over here, we started as a square root. It ended up still being a square root when I have a radical left over. If there's no radical left over, then yeah, it's not there. But whatever the index is at the beginning, that's what will be with the radical in the end. Okay, and that has to be there because the problem started off with that cube root. Okay? Alright, let's look at a couple other problems. So we are also going to have problems like this where we multiply. Okay, we have two radicals that are being multiplied together. And keep in mind, just like before, we want to think of the outside things as together and the inside things as together. So in this case, since my outside things, I have a 6 and a 4 and I'm multiplying, what would I get when I do that? 24. So then on the insides I'm going to multiply as well. So 8 times 2 is going to give me what? 16. C to the third times C. Nope. C to the fourth. Add the powers. D to the fifth times D to the third. D to the eighth. So that's what I'm going to get when I bring them all together. And now I take care of this radical just like I did before. Okay, so I've got the square root of 16, which is what? 4. Square root of C to the fourth.
2.
C squared. Square root of D to the eighth.
D to the 4th.
D to the fourth. Okay, so this is really what I have right now. Now understand at the beginning of this problem I had no even situation. Even though these were both even roots, I don't have even powers here or here. So I don't have to worry about absolute value even though I have it here. Okay, and actually I still have even, so it doesn't even apply. What's 24 times 4, do you know?
24 times 4?
Yep.
96.
96. So that's my final answer. 96c squared d to the fourth.
Why are those so much easier than the others?
Because the numbers worked out nice, that's why. And so what's interesting, here's what's interesting. If I would have tried to simplify this first and find a factor of 8 that's a perfect square and then do 3 divided by 2 and 5 divided by 2, that would have left me with a bunch of remainders, it would have left me with a bunch of numbers that were kind of trickier like the last two problems. But because when I multiplied, the numbers actually got nicer. I went from having two numbers that weren't perfect squares to a perfect square. I went from having powers that were odd to powers that were even and made the division easier. So a lot of the times when you do that simplifying first, the numbers will get nicer, which will make the problems a little bit easier for you. Okay, let's look at one more. Okay, so this one's similar, except what's different about it? What's the major difference?
There's the fourth.
The fourth, what is that called?
The cube, or not cube, the
Help him. The fourth what is this? What are we talking about?
I don't remember the name. I forgot the name too.
Fourth root. This is the fourth root, or the index is 4. But the process is the same. Bring them together. Okay, so go ahead and do that. Bring them together and try to finish this problem and see what you get with. So make sure that that little 4, that index stays in that little notch, if you will. I don't know what you want to call this, but it's got to stay there. Okay? So on the outside, I've got 2 times 3, that's 6. The inside, I have 8 times 2 is 16, x to the 8th, y to the 4th. All of that goes underneath the radical. Okay, and the 4 is still there. Okay, some of you slid the 4 over onto the 6. It's not where it goes. It stays in that little notch of the radical. Alright, now, does anybody know what the 4th root of 16 is? This is not 4. That's the square root of 16. Yeah, Dylan. 2. The 4th root of 16 is 2. Because 2 to the 4th equals 16. How about the 4th root of x to the 8th? Okay?
2.
X to the 2nd, right? Okay? 4th root of y to the 4th? Y. So here's where I'm at. Okay? The 4th root, so that's when the radical can finally go away. The 4th root of 16 is 2. fourth root of x to the 8th is x squared, and the fourth root of y to the 4th is y to the 1st. Then I have one more move, right? I've got 6 times 2, which is 12, so I can go through that. So let's notice here, we started off with even index. And the x's have odd power, so that's even odd, so I don't have to worry about the x's. With the y's, I have even here, and I have even here. So because the y ended up being to the first power, and that 1 is an odd number, so I have even, odd. So that y, we took care of the absolute value first. Let me go back for a second. Needs the absolute value, and then I can multiply the 6 times 2, okay? That's my final answer. The property that we're talking about in terms of multiplying radicals is, so long as the index is the same, you can multiply what's underneath those radicals together. And just like the last problem, oftentimes when we do that, the numbers get easier to deal with, okay? Now, I know you're not used to using radicals that are second. You're used to using square roots and cube roots, but you're not used to using radicals with an index that's really bigger than that. And that's something we're going to be doing in this section, okay? The process of using it is the same. Don't lose it until you're done simplifying.